All right, so let's talk a little bit about Quicksort. Let me do a quick introduction to it. So Quicksort is it appears to be a fairly simple algorithm um, that um, simply works with an array, takes it, takes that as an argument, and it also takes in um, as arguments two integer values that define the current array segment or partition that the quicksort algorithm is working on. So we have a base case condition that we can see here in quicksort that looks at the two indices, the low and the high indices of the array. And then we have an algorithm called partition. And so this algorithm called partition is really kind of um, the main portion of this sort algorithm. Notice that quicksort calls itself recursively. Let's go back to that. It calls itself recursively. And it works with two indices when it calls itself, from low to something that we're calling j minus 1, and then j plus 1 to high. Those two values that it uses to recursively call itself will be seen as the defining low and high index of the array that we're currently working on. So what is this j value that we're looking at? Well, primarily everything that's most important about quicksort happens in this partition method. In this partition method, quicksort sees a low index, in this case, let's say a value of 0, 1, 2, 3, 4, 5, 6, 7, 8. And on the high side, we see a value of 9. So each recursive call of quicksort will have a low index and a high index going from 0 to 9. And what you'll see in the code itself is that the algorithm will choose one particular value as a partition. And that partition value will be used and placed such that once we're done with the partition algorithm, the values to the left of that value, of that partition, what we're going to call a pivot point or a pivot value, values to the left are going to be smaller than the pivot. And then values to the right are going to be greater than the pivot. And so this value that's placed in here, when partition does its thing, it will return, once it's done, it's going to return the index at which that value, the pivot, has been placed. So in this case, let's say that the value 8, which was the pivot, has been placed into index 4. So it would return index 4. The next recursive call will then use anywhere from 0 up to pivot minus 1. So that would, or index minus 1, rather, j minus 1. So it's going to work from 0 to j minus 1. And the other half, the other second call in quicksort will work with j plus 1, right, which was a 5. So it's going to work with j plus 1 up to high, which is equal to 9. So it's going to split it up based on the partition value that gets returned. So what does that look like in the code? There's partition that we see here. It's going to see a low and a high value. The algorithm is going to do a few things that we're going to talk about in our walkthrough. And then it's going to return a j value, and this j value represents the place where the pivot has been selected or been placed. So it's going to return the position where the array element, in this case the pivot, which is 8, where it has been placed. Once this pivot value has been placed into its position, it will not be touched again, right? Since all of the values are less than our pivot and all of the values to the right are greater than, then there's no need to touch that. So the way pivot sort works, there's a partition algorithm. It places the pivot into its particular value, and it turns around and says, I'm done. Here is that location that I've placed it. And when it continues on, it calls quicksort with values to the left of the pivot. And then it calls quicksort again, right, with values starting from that pivot point to the high index. So from the low up to j minus 1, and then on the other side is going to work with j plus 1 to the high index. So it's really just placing each pivot into its proper position. So how do we select which value we're going to use as the pivot? Well, in this particular version of the algorithm, we're always going to select the value in the leftmost position. So a sub low will always be our pivot. And in this case, when we first, the first call to quicksort sees 0 through 9, so it takes the 8 as the pivot. But when we have completed one running of partition, quicksort will have two subarrays. When this 0 through 3 is used, 4 will be the pivot, right? Because that is now the a sub low. And at a later point in the algorithm, when we take the leftmost value, it's going to be an 11 that will be used as a pivot. So we'll step through kind of that process. We'll do a step through of the process so that you can see how we end up placing our pivot into its final position.